Hey guys, welcome to today's class. Have fun.
My name is Amadi Solomon Chiteber, and I'll be taking a topic today, indices and logarithm. But first of all, we'll start from indices, and I'll be giving you some of the laws of indices which you should take note while calculating. In indices, when you have any number to the power of a number times that same number to the power of a number like this, the resulting equation is always x to the power of a plus what? A plus b. If you have x to the power of 3 times s to the power of 4, this will give you what? This will give you x3 plus 4, which is what? S to the power of 7. So if you have 3 to the power of 3 times 4 to the power of 3, these are two different variables, so you can't sum them together. But when you have a number that is the same in this respect to the power of a number times this way, it gives you s3 plus what? Plus 4. So I hope you get. So coming to this, if you have x to the power of a divided by x to the power of b, it gives you xa minus b. Xa minus what? Minus b. So that's how we came about. So x to the power, any number to the power of 0 gives you 1. If you have a to the power of 0 is equal to 1. If you have 3 to the power of 0 is equal to 1. If you have 4 to the power of 0 is equal to 1. So that's that. So when you have x to the power of minus a is equivalent to what? 1 over what? X to the power of a. If you have x to the power of minus 1 over 2, it is the same thing as saying 1 over what? X 1 over 2. So that's that. So if you have x to the power of a bracket b, this b is multiplying a, not x. So we have what? If you have 3 to the power of 1 to the power of 4, or 3 to the power of 2 power of 4, this is equivalent to what? 3 to the power of what? 8. 4 times 2, 8. So that's how we came about this. So if you have x 1 over a, it's the same thing as saying a to the power of what? A square root of what? X. This is just like saying x half. That's the square root of what? X. This is equivalent to the square root of x. If it's x to the power of 3, this is what? The cube root of what? X. If it's this is the fourth root of what? Of x. So that's that for that. So if you have x a to the power of b, a over b, s to the power of a over b is the same thing as saying what? B, which is our root, to the power of what? X a. So if you have 4 3 over 2 is the same thing as saying to the square root of what? Of 4 times what? Times 2 times 3. The square root of 4 times 3. If you have 4 over what? Over 3. This is the cube root of 4 times what? To the power of what? To the power of 4. So that's the laws you should have with you. So coming to logarithm. In logarithm, these are some of the laws you must take note of. If you have log mn, this is the same thing as saying log m plus log n. You should take note of that. Log m plus log n. Log m plus log n. If you have log 3 plus log 2, this is the same thing as saying what? Log what? Log 3 times what? Times 2. And that's log 6. It's totally different from saying log 3 plus 2. Log 3 plus 2 is not the same thing as log 3 times 2 in brackets. When it's log 3 plus log 2, that's when you have log 3 log bracket 3 times 2, which is log 6. So if you have log m over n, it's the same thing as saying what? Log m minus n. So log m minus log n will give you log m over n. So if you have log m to the power of p, this is the same thing as saying p log m. this p goes to the back, so that gives you p log what? M. So some of the theories I also want you to know is when you have n which is equals to a to the power of x, n equals to a to the power of x, this is the same thing as saying what? Log n, which is equals to what? Log an, which is equals to x. N equals to a to the power of x. It's the same as saying log an equals to x. This is how I did it. Log times n here will give you, you have to use a, so as you have to use the variable here a, so that you can cancel this a here. So log an equals to log a to the power of x. So this a will cancel. That gives you log an equals to x. So when you have log b, when you have n equals to bx, you can't go and have something like log an equals to x. No, it has to be b. So that's that. So when you have something like this, log 100 equals to 110 over 2, so you multiply both sides by log 10, so that gives you log 10 3 equals to what? Log 10 10 to the power of 2. So log 100 is equals to what? 2. So another theory is when you have your log sp equals to n, log sp equals to n, that's the reverse now. How you get p equals to s to the power of n is by carrying x to this side, x raises n, it gives you what? P equals to what? S to the power of n. So that's just some of the logic I just wanted to know that will help us in solving equations. So going back to our set, we're going to be simplifying some equations. So looking at indices and logarithm here, we picked some equations. So we are going to be solving some of the WAEC equations here. Number 31 says to simplify 4 over 25 to the power of minus 1 over 2 times 2 to the power of 4 divided by 5 over 2 raised to the power of minus 2. And we are also going to be simplifying 56s to the power of minus 4 divided by 14x to the power of minus 8. So from there, this is the equation. So from here, 4 over 25 to the power of minus 1 over 2 times 2 to the power of 4 divided by 15 over 2 minus 2 will give us this. So 1 over what? This is 1 over 4 over 25 half from one of our laws times 2 to the power of 4 divided by 1 over 15 over 2 to the power of 2. So that gives us 1 over the square root of 4 square root of 25 times 2 to the power of 4 divided by 2 over 15 to the power of 2. Not 15 over 2 to the power of 2. This goes up, then 15 comes down. When you have 1 over x over b, this is the same thing as saying b over x. And as saying b over x. So from here you have your 1 over the square root of 4 and the square root of 5 is plus or minus 2 over 5 times 2 to the power of 4 divided by 2 over 15 the square root. So from here you have plus or minus 5 over 2. 5 goes up just like from calculated here. 5 goes up, 2 comes down. So 5 over 2 plus or minus 5 over 2 times 2 to the power of 4 times. So this gives you what? 15 to the power of 2 divided by 2 to the power of 2. You understand? So when you have a times a divided by x over b, because of this division sign, if if we change it to multiplication sign, this automatically changes to what? To b over what? X. How? We have a over what? This is divided by x over b. So this is the same thing as from here. We have our a times what? Our a times what? X over b. A times b over what? Over x. So that's how. And so we have our 5 over 2 times 2 to the power of 1 times 15 square over 2 square. So from here you have our 5 times plus or minus 5 times 2 to the power of minus 1 times 2 to the power of 4 times 3 times 5 to the power of 2 times 2 to the power of minus 2. This is 15. 15 is same as 3 times 4, 3 times 5 to the power of 2 times 2 to the power of minus 2. So from here you have plus or minus 5 times 5 over 2 times 2 minus what? Minus 1 times 2 to the power of 4 times 2 to the power of minus 2, which is from here, times 3 to the power of 2. So when you have 3 to the power of 2 times 5 to the power of 2, it's the same thing as saying 3 times 5 square root of 2 bracket square root of 2. So from there, that leads us to here, to this place. So 5, all of 5 to the power of 1 plus 5 to the power of 2 is the same thing as 5 plus 5 to the power of 1 plus 2. That gives us 5 to the power of 1 plus 2. So, and for this other place where you have 2 to the power of minus 1 times 2 to the power of minus 2 times 2 to the power of 4, that's the same thing as saying 2 to the power of minus 1 plus 4 minus 2 times 3 to the power of 2. So when you calculate everything, it gives you plus or minus what? 5 to the power of 3 times 2 times 3 to the power of 2. So when you calculate, it gives you plus or minus what? 2250. So the next equation is equation 32. Simplify this. So if you have to simplify it, we have 56x to the power of minus 4 divided by 14x to the power of minus 8. So when you factorize, you have your 56 over 14. You bracket them. So x, you are factorizing now, x to the power of minus 4 minus, because of this division, I told you when you have division sign in indices, if you have to work with power, it will convert to minus. So division is minus, while multiplication is plus. So minus 4 minus 8, that gives you what? 14 divided by 56 gives you 4. So 4x minus 4 plus 8 gives you 4x to the power of 4. So that's the answer for this equation, 4s to the power of what? To the power of 4. So going to logarithm now, we're going to be solving some problems in logarithm. So we're going to be solving equation. So we're going to be solving number 9, which is a wire equation. If log x minus log bracket 2x minus 1 is equals to 1, find x. So log x minus log 2x minus 1 is equals to 1. So find x. So log bracket x over 2x minus 1 is equal to what? Is equal to 1 from our laws here. We have log m minus log n is the same thing as saying log bracket m over n. So that's what we did here. So log x over what? 2x minus 1 equals to 1. So from here now, we told us that if you have log x is equals to 1, this is the same thing as saying what? The same thing as saying this your log. If you take it to this side, if it's log base a x equals to 1, this when you take it to this side, it raises this one, so it becomes what? X equals to what? A to the power of 1. Then for this side, if you have to bring this a to this side, it becomes log this one, log a, which is equals to what? Log ax, which is equals to what? Which is equals to 1. This one comes down. So to give you this equation. So for this now we have log x over 2x minus 1 equals to 1. So let's assume that this log here is to the power of 10. So anytime you are given a logarithm equation, if the base wasn't actually indicated, if the base isn't indicated, just assume it to be base 10. So from this we have what? X over 2x minus 1 equals to what? Equals to 10 to the power of 1. So this log, we are assuming that the base here is 10. So this 10 raises this one up. So you now have x equals to what? 2x minus 1 times 10. X equals to what? This multiply this. This multiply this. So x times 1 is 1, is x, which is equals to 2s minus 1 times 10. We give it 2s minus 1 times 10. So here x equals to 20x minus 10. So 10 is equals to what? 20x minus x. So if you subtract this, 19x is equals to 10. So x is equals to what? 10 over what? Over 19. So that's the answer for that equation. So going to the next problem, which is this 2x to the power of what? To the power of 2 minus 3. That's 12a. I'm solving 12a now. So they said 2x to the power of 2 minus 3 times 2s 2 to the power of x plus 2 equals to 0. Let y be equals to 2 to the power of x. So that's what we have here. That's what we have here. So if y is equal to 2 to the power of x, we have y square, which is equals to y square minus 3 times y. Our x, 2x to the power of 2 to the power of x is y. So 3 times y plus 2 equals to 0. So we have y square minus 3y plus 2 equals to 0. So when you factorize this, it gives you what? Y minus 2. The bracket of y minus 2 bracket y minus 1 equals to 0. So from here now, y is equals to 2 and then y is equals to 1. So we haven't end. So what we still have an equation. So when you equate y, which is equals to 2, and y, which is equals to 1, into this equation, so that gives you what? 2x. Since y into this equation, so we have to equate this y, which is equals to 2 and 1, into this equation. So we have our 2x, which is equals to y. So you equate it into this equation. You equate this y equals to 2 and y equals to 1 into this equation. 2x minus equals to y. So 2x, 2 to the power of x equals to 2, and 2 to the power of x equals to 1. So from here we have 2 to the power of x equals to what? This 2 to the power of 1 is the same thing as what? 2 to the power of 1 is the same thing as what? So that's equals to 2. 2s equals to 2. 2s equals to 2 to the power of 1 is the same thing as 2s. 2 to the power of x equals to 2 to the power of 1. So, and 2 to the power of x equals to 2 to the power of 0 is the same thing as what? 2 to the power of x equals to 1. So the essence of bringing it down to this is so that we can find the answer to this x. That was what we did earlier from some of our laws. So from our theories in indices. So from here, these two cancel these two, now become s equals to 1. So this, whereas this x becomes what? 0. 2 cancel 2, s equals to what? 0. So if we had 2 to the power of x equals to 4, 2 to the power of x, how many times can 2 go to 4? So 2x equals to what? 2 to the power of 2. So here 2x equals to 2. So that's the essence of this. So when you have any equation carrying an unknown to carrying and known as power, as its power, the next number on the other side will be you break it down so that it can be able to form an equation where 2 carries a known number. So if you have 2 to the power of x equals to 8, this equation now we try to break it down where by 2 carries what? A number, so that it will be similar to this, so that x can be what? Can be found. So you have 2 to the power of 3 here. So 2 cancel to x equals to 3. So take note of that. So we also take another problem. Simplify log 8 minus log 4 over log 4 minus log 2. Log 8 minus log 4 over log 4 minus log 2. So from this you have your log bracket 8 over 4. From our laws, log bracket 8 over 4 is written as log 8 minus log 4. So over log 4 over 2, that gives you what? Log 2 over what? Log 2, which is equals to 1. So therefore that's the answer for that very simple equation. But when you have log 8 minus log 4 as your equation, log bracket what? 8 over 4 gives you what? Log 2. So this is the answer for this equation. So that's that for that. So we have another equation here where we have log x minus log y equals to log z. So when you have something like this, log x over y is equal to log z. So from here, x over y is equal to z. So x is equal to y over z. So this equation can be simplified to this form. The same thing with this. When you have this equation, you have to simplify it. You have log x plus log y. This 2 log y becomes what? Log y square. 2 goes here, becomes log y square equals to 3. So log x times y square is equals to 3 plus brings about this. So xy square is equals to 10 to the power of 3. So sy square equals to what? 10 to the power of 3. This is how to simplify. So they say express in index form. So this is how you express it in index form. So when you're given an equation like this and you're asked to express it in index form, you follow this pattern. So that's that for indices and logarithm. So I told us last time that we're going to be teaching us how to use our logarithm table. So almost the same thing with our number logarithm, but this has to do with numbers. So when you have your logarithm in numbers, you must know how to use your logarithm table and your anti-logarithm table. If you don't have a logarithm table, you can go to the back of your textbook. There you get a table for your logarithm of numbers and a table for your anti-logarithm of numbers. So these are some of the laws, just like we've actually taken. Just remind ourselves, a times a is the same thing as saying log a plus what? Log a. A divided by b is the same thing as saying log a minus log b. A to the power of a square root of b is the same thing as saying log b divided by what? By a. Log b divided by what? Divided by a. That's a square root of what? Of b. So when you have a to the power of b, the same thing as saying what? Log a times b when it comes to log of numbers. So when you have 0.0x where x is greater than 1 or equals to 1, you start on your logarithm table in this form: 2 bar 1, 2 bar 2, bar 2. This is bar 2. But when you have this on your numbers, your logarithm column, you have what? Log A log B divided by what? A. But when you have this as your number, your logarithm column, you have bar 2. When you have 0.x, it becomes what? Bar 1. You are following the number of zeros which forms your bars. So when you have x point A, where x and A are what? Are numbers greater than 1 or equal to 1. X is a number greater than 1 or equals to 1. X is not 0 now. But when x becomes 0, it gives you what? Bar 1. But x is a number greater than or equals to 1. And then A is a number greater than or equal to 0. Then you start with 0 point. But when you have x A point B equals to, on your logarithm column, you have what? You start with 1 point. So the number of what? The number of movement the point can make from the first number. So from here, the number of movement that can be made is 0. There is no movement that can be made from x because point is at x. But when you have x A point B, the number of movement this point made from x was what? 1. So that gives you 1 point. So when you have x A B point C, the number of movement this point made from x was what? Was 2. 1, 2. That gives you 2 points on your logarithm table. You'll be applying this, dealing with logarithm what? Logarithm of what? Numbers. When you come to the logarithm of numbers. So take for instance, we are given an equation 2.067 divided by 0.0348 times 0.538 all squared. So coming here to solve for this equation, your number, we have 2.067 as a number here. So if you want to convert it to your logarithm of numbers, you go to your table. This 2.067 will give you what? 0 point, like we told you earlier, like I told you from the laws I put out. So these 2 points, the number of movement this point moves from this from the first number is what? Is 0. So that gives you 0 point. So we are going to be looking for the logarithm of these numbers 2067. So when you go to your logarithm table, how you get that number? Looking at your logarithm table, you have several numbers, and then you have what? You have their differences. Is that not so? So coming to this point, we have 20 point what? We have 20.267. We already gotten what should be our initial from this number, which is 0 point. If it's 0.03, our initial will be what? 2 bar. So from this 20.67, we are going to our table now. We'll go where number 20 is. Then a difference of 6, which is 3139. 20, difference of 6, which is 3139. Then another difference of what? Of 7. 20 under 6, difference of what? Of 7. So we have 3139 plus what? Plus 15. You are going to be adding it. So when you have 3139, so when you have 3139, the difference of 7 was what? 15. So when you add this number, it gives you what? 14. 3 1 plus that one 5, then 3 1 5 what 3 1 5 4. So we have 20 difference 20 under 6 difference of what or 7. So that gives you 3 1. That gives you 3 1 5 what 4. 3 1 5 4. So from here our 0.0348 gives you bar 2. Then when you go to 34, difference of 8, you come to your table. 34 difference of 8. 34 under 8 is what? 5416. 5416. So we have from here, we have our 0.0348, which gives you our bar 2.5416. You add your what? 34 under 8 here. So coming to this particular place, 0.538, it gives you what? 1 bar 1, which is because of this 0 point, we are putting the bar according to the number of zeros before the point. So this is bar 1. So you go to 53. You go to 53 under your logarithm of numbers. Now logarithm of numbers, you go to 53. You go to 53 under 8. Under 8, 53 under 8, that gives you what? 7308. So you insert that 7308 here, 7308. That gives you what? The logarithm of this number. This is the logarithm of this number. The logarithm of this number. This is the logarithm of this number. This is the logarithm of this number. So from that, your 2.06 divided by this 2.06 will divide what? Will subtract under your logarithm column. This will subtract, just like we said from our law, when you have division, you subtract the logarithm of that number minus the logarithm of what? Of b. So from here you have 2.06. So the logarithm of this number will minus what? The logarithm of this plus the logarithm of what? Of this. Because we have a times a, you have logarithm of a plus the logarithm of a. So from here you have the logarithm of this plus the logarithm of this. So this is the logarithm of 2.067, which is 0.3154. So the logarithm of this plus this is this. So 8 plus 6 is what? 14. We write down 4, carry 1. 1 plus 0 is 1, plus that 1 here gives us 2. So 4 plus 3 is 7. So 7 plus 5 is what? Is 12. You write down your 2, you carry 1. So this minus 2 plus minus 1 is what? Minus 2 plus minus 1 will give you what? Will give you minus 3 plus our 1 here. So minus 3 plus this one that is remaining from this 12 here will give you what? Minus 2. So we have minus 2.2724. So when you bring it here, this to this side of the table, you subtract, since this divided by this is the same thing as the logarithm of this number minus this, you now become 0.3154 minus 2.2724. So that gives you what? 4 minus 4 will give you what? Will give you 0. So 2 minus 5 will give you what? Will give you 3. 7 minus 1 cannot go. You borrow 1 from here to here, it becomes 7 minus 11, which is what? Which is 4. So 2 minus 2 will give you what? 0. So this 0 minus minus 2 will give you what? Will give you plus 2. So that gives you what? 2.0429. So divided by 2, we told us the square root of that number. So the square root, looking at this from here, we have the square root of x, which gives us this, whatever we get from this minus this, will not be divided by 2. That's from one of our laws here. Whatever you get, the logarithm of a will not be divided by what? By the square root, or if it's a cube root, it will be what? Over 3. So this is square root, so you have over 2. So divided by 2 will now give you 1.0215. So whatever you get here, you must take note of this 1 point. So to convert it back to your number, you must make sure that the point is one move away from what? From your first number. One move away from what? Your first number, provided the number is greater than or equal to 1. So we are going to be looking for the anti-logarithm. Unlike logarithm, where you take the two numbers, you take the both from the number for after the point, the number before the point. In anti-logarithm, you only take these numbers only. You only consider these numbers. So from your anti-logarithm table now, you go to make sure anti-logarithm of numbers. You go to 0.02 under 1, which is 1050 under 1, 0.02 under 1, 1050. The difference of what? The difference of 5, and the difference of our 5 here is what? Is 1. 0.02, the difference of our 5 is what? 1. So you add 1 here, so the answer becomes what? 1051. But since we have 1 point, our 1 signifies that our point must be one move away from the first number, which is 10.51. So when you are converting this one back to a logarithm, here will become 1 point. So you look for 10 under 5, difference of 1 will give you this. So let's cross check. So you go to 10 under 5, 10 under 5, the difference of what? 10 under 5, the difference of 1. So we have what? 0.2152 plus 4, which is 0.21 what? 0.216. So you come here, 0.216. It's almost the same thing. 0.215 is the same thing. It's equivalent. So we have 1.0215. So that gives you what? Your answer. So we'll go to another example. So we'll consider this example here before us, where we have 1.376, the cube root of 1.376 over 0.007 e power of 1 over 4 times the 0.27 to the power of 3 over 0.27 to the power of 4. So from here, your number, then your logarithm. Make sure you show that table. So your number is 1.3 what? 1.376. So from this 1.376, you go to your logarithm table. From our 1.376, we'll start with 0, since our point is at no move. There is, you can't make any move. There is no move from the first number, so it starts from 0. If the point was here, that means is one move away from your first number, which gives you 1 point. But since it's at no move from your first number, it becomes 0 point what? From whatever you get from 1376. So when you check your logarithm, your table, 13 under 7, 13 under 7 gives us 1367. It gives us 1360 what? 7. under 7, difference of what? Difference of 6, which is 19. So our difference of 6 here is what? Is 19. 13, 7, under 7, difference of what? 6, which is 19. So when you sum these two, it gives you what? Gives you 9 plus 7 is 6. 6 plus 1 is 7. Plus that one, 8. So we have 1386. So 0.13 So because of it's carrying a cube root, you divide it by what? By 3. So when you divide it by 3, it gives us what? 0.0462. So that's that for our first, the logarithm of our first number. So going to the next number, where you have 0.007, so that gives us what? 3 bar. 1 2 3 3 bar point. When you check for the logarithm of 7, the logarithm of 7, since from this table we don't have 7 here, so what you go to 70, because this number is the same thing as what? 0.0070. You understand? So you go to 70, and 70 is what? We have 845 what? 8451. 70 under 0 is what? 8451. So you put your 8451. So 3 bar point 8451 divided by 4 gives you what? Your answer here. So but in dividing this, it will be easier for you to break down this number into this. So your bar 4 plus 1.8451 is the same thing as what? 3 bar point 8451. So when you add this to this, it gives you bar 3 point. So this is bar 4 plus what? 1.8451. So we did it like this so it will be easier for you to divide. So this divided by 4 into bar 4 will give you what? Bar 1. So 1.8451 divided by 4 will give you what? 0.4 into 8 cannot go. You bring 1 here, which now give you 4 into what? Into 16, which is 4. Then 4 into 24 is 6. 4 into 5, 1. Then that gives you your what? Your answer. Sorry, 4 into 1 is 0. 4 into 8 cannot go. 0. You bring 1. So 4 into 18 can go 4 times, which gives you 16. 16 minus 18 is 2. 4 into 24 is 6 times. And then 4 into 5 is what? 4 into 5 is 1 times point what? 0.5. So that gives you 0.46 what? 462. So that gives you what? 0. What? 1 bar 1.046 what? 2 bar 1 0.0462. So from there you have your answer. But since this over this, I want to calculate for this first. You can calculate for this first and then subtract it from this. But I want to calculate for this and then add it to this. So you understand? So 3 divided by this number over 4 divided by this will give you this. We give you this. We give you 0.0462 minus your bar 0.0462. Now give you your bar 1.046. 4613. 4613. Sorry. So give you 4 into 1. 0.4613. 1 point. So give you 1 by 1.46113. So when you subtract them, it will now give you what? 3 minus 2 cannot go. You bring 1 here. 3 minus 12 is 9. 1 minus 5 is 4. 6 minus this cannot go. You bring 1 from here. You bring 1 from here. So immediately you carry 1 from here, it becomes bar 1. If you subtract 1 from 2, it becomes what? 1. If you subtract 1 from 1, it becomes 1. If you take 1 from 2, it becomes 1. If you take 1 from 1, it becomes 0. If you take 1 from 0, it becomes what? Minus 1. So that's what we have here. So you take 1 from this 0, it becomes minus 1. So when you impute it here, it becomes 6 minus what? 14, which is 8. Then here becomes 9. 4 minus 9 is 5. So you have 0.5849. So from here, when you subtract bar 1 minus bar 1, bar 1 minus minus 1. So minus 1 minus minus 1 will give you minus 1 plus 1, which is what? 0.5849. So that's that for this. So we have to calculate for this now. 0.27, if you check your table, this is 1 point. The logarithm of 27 under 0 is what? Is 4314. 4314. So when you have it to the power of 3 now, it will give you what? By 1.4314 times 3. You have it to the power of 3. You have to multiply by 3, which gives you what? 2 bar 0.2942. 2 bar 0.2942. So that gives you the equation. So coming to this particular place where you have this same number to the power of 4 is that same 1 bar 0.4314 times 4, which gives you 3 bar 0.7256. So when they divide each other, it simply means we are subtracting from them. So when you subtract it, 6 minus 12 will give you 6. So here it remains 3. You carry 1 from here. 5 minus 13 is 8. So 2 minus 7, 2 minus 8 is what? Is 6. 7 minus 2 cannot go. So you carry 1 from here. Carrying 1 from here becomes bar 3. Here becomes what? Bar 3. So bar 2 minus 2, you take 1 from it, it becomes minus what? 3. So here becomes what? Bar 3. So 7 minus 12 is 5. Minus 3 minus minus 3 will give you minus 3 minus minus 3 will give you what? Minus 3 plus 3. That gives you what? 0. So you have 0.5686. But looking at this, we are having this multiplied by this. So we have to bring this down. I have to bring this down. 0.5849. 0.5849 will now be plus this, which will now give you 1.1535. So when you check your logarithm table, the anti-logarithm of 15 under 3, the anti-logarithm of 15 under 3, difference of 5 is 1424. Is 14 what? 24. But since our 1 is here, 1 point, so our point will be here. So this is 1 move away from the first number, which gives you 14.24. So this is our final answer for this what? For this problem. For this what? For this problem. So I'll just take one other example where we are being asked to simplify this. 0.81 times 10 to the power of minus 5, 2.25 times 10 to the power of 7. So from this, we know that 81, the square root of 81 is 9, and the square root of 225 is 1. Is what? Is the square root of 225 is what? Is 15. But from here now, we cannot get, while it is with a point, we cannot get our solution. So first of all, we have to break down this. So in breaking down this, 0.81 is the same thing as what? 81 times 10 to the power of minus 2 times what? Times 10 to the power of minus 4 times 10 to the power of minus 1. Also, this number must we must change it to a number whereby the square root of that number will give us a whole number. So from this will give you 81 times what? 10 to the power of minus 2. And 10 minus 5 will give you 10 minus 4 times 10 minus 2. Minus 4 minus 1 will give you minus 5. So this 225 is what? Is 225 times 10 to the power of minus 2. And 10 to the power of 7 is the same as what? 10 to the power of 8 times 10 to the power of minus 1. 8 minus 1 will give you what? 7. So from here we have 81 times 10 to the power of minus 4 divided by 225 times 10 to the power of what? 8. So from here, this is indices now, right? We are simplifying it. So from here we now have 9 over what? 9 over 15 times 10 raised to the power of minus 2 divided by what? 10 raised to the power of 4 minus 4. The square root of 10 raised to the power of minus, the square root of 10 raised to the power of minus 4 is what? Is equivalent to saying 10 minus 4 times 1 over 2, right? This is the same thing as what? 10 minus 4 square root of 10 minus 4. So these 2 will cancel this form. It will give you 10 minus 2. So that's what we have here. 10 minus 2 over 10 to the power of 4. So 0.6 times 10 minus 2. Then this divide by brings about the minus sign here, minus 4. So 0.6 times 10 to the power of minus 6. So that gives you what? 6 times 10 to the power of minus 1. 0.6 is 10 as 10 to the power of minus 1. So 6 times 10 to the power of minus 1 times 10 to the power of minus 6. So 6 times 10 to the power of minus what? Minus 7. So that gives us the simplification to this problem. Thank you. My name remains Amadi Solomon Chidebere. So if you have any question on indices and logarithm, you can just leave it on the comment section and we'll reply you. Thank you so much for subscribing with us. God bless.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.